In this introduction to Rstudio for data analysis, I'll be covering these topics. When we open up Rstudio, this is what we see. We have a window on the left called a console, and then there's two windows here. What you want to do, guys, first of all, is to create a folder where you're going to save all your R stuff, and then navigate to it. So click through to it. And then we want to tell Rstudio that that's the folder we're working with. We want to save to that folder, we want to retrieve data and so on from that folder. One way to do that is go up here, More, and click Set as Working Directory. Now when we click down on that, you see on the left console here that you have this command setwd for set working directory and then the path. So this console is a place where that takes in commands and executes and outputs textual information. To communicate with Rstudio, we don't really want to be typing stuff into the console, though we can, because sometimes we'll make mistakes in our commands and then it's just going to be left on this console window. So our console will be a mixture of good stuff and bad stuff. We want things clean. So to do that, we want to work through an R editor. So one way to do that is click on this green button here. We'll click on R script. Okay, so we have this page called Untitled at the moment, and it's got number 1 here. It's got a first line to receive code. We can use this thing like a calculator. Let's just do something. 3 minus 1 and press enter. Now it jumps to line 2 and you can see it hasn't given us the answer. This is because the editor it doesn't execute things, okay? It's just a receiving code. To actually run a particular line, I just click anywhere on that line. I don't have to highlight the thing like most newbies think I have to. It's a bit tedious. Can click anywhere at all and go over here and click run. What that does is it transfers this line here into the console and executes. So it's giving me the answer 2. Great. A power of R is that it works with things called objects, and objects is, you can imagine, like a bin that contains, it could contain text information, it could contain numerical information, it could contain a mix of text and numerical information. Depends on what the object is. So there's loads of types of objects in R. Now let's kind of do another kind of command. Let's say do +2. This time I want to tell R to create an object with that answer. To do that, we need to give it a name, and we have to tell R to assign that thing, this 7+2, to the object. How you do that is you can use this arrow made up of 2 symbols like this, and we'll give it a name, the object a name. The name should be something like, can reflect what you've done here. I'm going to call ans for answer, and if I run that line, I'm going to click run. It's transferred that piece of code into the console again. What you should notice as well, guys, if you look on the right pane, is it's now appeared here as well. This pane here keeps a track of all the objects that we're creating in our session. Right. There is a restriction on what we do with this name. We cannot start with a number. If I do 2 ants, we cannot start with a number, because if we start off with a number like this and press enter, you can see there's an error message. So the first character cannot be a number. Now I've created an object called ants, which is 9. Now let's kind of output ants again and click run. Now what we notice here is that it says ants not found, ANS, as opposed to little ANS. R is case sensitive. Right? That's one of the things that newbies kind of forget. So little ANS, different big ANS. One other thing is about this assign operator is, instead of doing this arrow, we can use equal. So I could have equally just replaced this by an equal sign. Let's call it ants.to. Create another object called that and run. You see over here now it's created that object. Right, that's the first bit. Now let's do loading data. So we have a data set and want to load it. Right, how you load it depends on what format your data is. Here I've got a text file. If you've got some kind of fancy file like an Excel or whatever file, or SPS, whatever, you can try clicking on this import data set, but what I find is this option here can vary from time to time. I don't know why. Okay, so I prefer just to use commands. Right, to kind of load a text data set, I use the command for that is read.table. If I do read dot, you can see the options here. So that's going to be a CVS file, like from an Excel spreadsheet, okay, and all these other types. So it's of the form read dot something. I'm going to do read dot table, open bracket, space and 2 for speech, and then I type in the name of the dataset, alligator.txt, and then I have to know whether this dataset contains labels on the first row or not. So I can click on this first, click on alligator.txt, a window opens. You can see this is the dataset, and it's got two variables, weight and length, and you can see in the first row it contains labels. If I don't tell R it's got labels, it'll think they're numbers, and then I'm going to get to problems. So by default it'll kind of think that's numbers. So to tell we have a label, we'll go header, and R has got this intelligent completing kind of function, equal, and then type true with a capital T, or just T like that, and that means true. We have to give this object a name, because otherwise we won't be able to refer to it, so we've got to assign it something. So let's do that. Give it something again short, because you might have to type it in over and over again. I'll just call it dat. I'm going to run that. See over here, we've now created a data object called dat, 25 observations, 2 variables. To see, I mean, this is kind of verified it's gone in properly, but if you want to actually see the data set, some people just like to see it, so let's just type dat and run that line. Okay, so in the console now, it's given us the data set right there. Now that's okay for like 25 observations, but if you've got like thousands of observations, you're only dumping it onto your console. So we can do a head and dat. That will give us the first 6-ish, yes, 6 observations. So you can see it's gone in properly, the labels are fine, you've got no corruptions in the labels, and the numbers fine. Now we've loaded the data, we want to do some stats. So look at the variable here. Let's look at length. You can see it's continuous data, and plots for continuous data include histogram, boxplot. Let's do a histogram. The command for that is hist. Right, now I'm going to tell R that I want to do a histogram on length. There are various ways to do this. Now here's one way. First, tell it the name of the dataset, it's dat, followed by this $sign, followed by the name of the variable. So when it does a $sign, it already knows I've got these 2 variables in there. Click on length, and then run that line. You can see the histogram has appeared in this bottom right. Now let's do a box plot. Run that. You can see the bottom here refers to the quarter 1. This is the median. This is the upper quartile. That's the maximum value. That's the minimum value. To get those numerical values, we could do summary. And here you go. Those are the figures. I said there's more than one way to refer to variables. So this is one way. Name of the data file object, $sign, and the variable name. Now here's another way. Let's do a histogram again, but this time use this other command called with, and it works like this. We'll go with, open bracket, name of the data object is dat, comma, and then the command hist. Now when we do that, it's telling R with the dataset name dat, do the command. So I want to do a histogram of length. And notice we don't have to type in dat dollar, because it's already knowing that we are dealing with length. Like that. And run. There you go. So that's option 2. Third option is often, I've just seen often taught on the beginner's course in R. It's called attach. So what we do is attach dat, enter. What this tells R is from here onwards any command will be on the data dat. Alright, let's do summary again. and this time type in the name of the variable by itself and run that. Let's see, oops, have I made a spelling error here? No. The thing is, guys, this is what I was saying. Sometimes when you're writing more than one line of code and you might want to you need to run the block, so you can look over here to see if you've created something. Obviously here I've already created that from above, right? So what I want to do is do this, do that, and run the line. So what I did there was just click where I want to start, hold down the shift button, click at the end where I want to end, and run. Okay, that's better. Okay, that's got that done. The thing about attach is it allows for like neat looking code, because I don't have all this extension to reach a variable. I don't have to go with and then, you know, before I actually type the command. So what's going for attach, a pro for attach, is it keeps the code looking clean, but there's many downsides to it. So often, you know, experienced R users will warn you from it. I'm not going to go into that because, you know, it's just a practical thing. So if you just heed the warning, avoid it. But if you're doing an intro course and your professor say you use that and it's fine, then just stick to that. When we finish with the dataset, always important to detach. Oh, I spell that right? Detach. There you go. Now you know it's spelling right, because if it's a proper command, you can see it's highlighted in blue. Right, you can see as we're going along now, I'm creating now quite a few lines of code. If I were to come back to this, I would be spending, you know, quite a while understanding what I've done previously. So what you want to do as you're working along is to add like comments to see what you're doing. How you can add comments to tell R not to read a particular line is do a hash. Everything followed by that hash is not read by R. And you can see it's lined in green. So here I might do creating objects, okay, and then space things out so you can see groups of, you know, it's like a paragraph in writing. Here I'm kind of loading data and summary stats. Okay, that's the next block. So that's one place to put comments at the top of a block of working stuff. Another common place is to stick it at the side of a command. So like here, if I want to remind myself that I must check whether there is something in the header here, I could put it at the side here. Check first row of data for kind of a header, okay, text like that. And if I run that line, again, okay, it's run. But now, suppose I forget to put that hash sign, I put it right on the side. I think you can guess what's going to happen. You get an error message because it's trying to read that as a command as well. So hash. Pretty early on, we want to be saving our code. We want to be saving stuff. So how you can do that is save your R code, click on here, give it a name. First R, I'm going to call it. The suffix is .r, and it should register up here. There you go, like that. Do I save stuff in the console? Newbies often want to know this. No, guys, because, as I said, look, it's full of good stuff and rubbish. And if you were writing up a report, you don't just want to be copying and pasting this stuff into your report. You want to create nice tables and transfer this in properly, okay? So you don't want to do that. The other thing you can save are plots. So if I go here and I want to plot, I can click export. I can save this image. If I want to see this bigger, because it's like a small window, click on zoom. It pops up and I can see a nice big plot. I'm going to do right click and save here as well. Right. The other thing you may want to save then are all the objects, because because you've saved the code, it doesn't save the objects, it just saves this stuff. Now that's fine if we've got a small kind of session, because if when we reload all these commands here, we can just run it as a block and we'll get all the output again. But if it's really long, if it's a long session, we've got loads of code, maybe you don't want to run the whole thing, in which case you want to save the objects as well. It's what we call the workspace. To do that, again, you can see there's a kind of a disk here, because press on that and give it a name. Press it so it matches what you call the R editor, R commands. The suffix here is R data. That tells it it's a saved image, basically the same as typing save image, this stuff here. Now let's close up the R session and reopen and resume. Okay, so I've taken a break, only I haven't, and I've opened up Rstudio again, and the whole thing's empty. But I want to resume the session. So what I can do over here is reopen, file, open file, and go to my folder, .r, that's my code, there you go. But notice, look, all my objects have gone. Okay, all the objects have gone. Since I'm starting here, I should also remember set working directory. There are no objects. So I could run this whole thing again as a whole block and create my objects by like that and press run. Or that's okay for a small session. Or you could load back the objects. So just showing you that does work. Right? Notice the icon here, data, and the objects all appear, and I can just continue from the bottom line. Great. Still on the thing of tidying up. Suppose this session's going on and on. I create loads and loads of objects. Let's say I want to get rid of some of these objects. I want to get rid of this one here, ants2. The command to do that is rm for remove, name of the object, ants.2. Run that. It's gone. Say I want to remove everything from the objects. Okay, all objects. The fast way to do that, instead of you don't want to be doing it one by one, you go list and then equals ls open close brackets and run that line. Everything disappears. Not that you really need to, but some people like to clear the console as well if they're beginning a new session. Alright guys, to do that just click anywhere in the console, I think Control and L. Okay, that clears it. Okay, so let's put here just hyphen tidying up. Okay. Right, let's run this thing again. Let's run that block. Okay, create these objects. Alright, now what am I going to do next? What I'm going to do next is show you a common error students make when they're because when you are writing code, you don't have to run it line by line. So you know what story you want to tell. You might want to just do a few lines of code and run it as a block. So let's just do this thing. Let's say I create a number 1 plus 2, save it into object A, and B is going to be the answer to A plus 4. Okay, you're writing code and then you decide to run it. So you just highlight the your end line and you click run. What happens? Oh, object A not found. And you think, why isn't it running? It didn't look right. Yeah, it's because you didn't run the previous line. You didn't create this object A. And how you know there should be a problem is because you need this A and there is no A in your object here, in this created here. So that should tell you you need to go back up here, highlight down here and run. Now created the objects. Okay, so hash here, the lesson is not to forget earlier code when you're running the later code, if the later code depends on the earlier code. Right, one last thing. I'm going to do a one sample t-test. Right, so let's look at the mean. What's the mean of this, of the length? Okay, it's 84.96 for this alligator dataset. Alright, suppose we want to test that the population mean length is about 90. Then what I can do is do a t-test. T.test, and then how this works is the name of the dataset, comma. We want to test that the mean, true mean is 90, so mu equals 90, and then we can run that. What you see here is given the t-test, it's given the p-value. Now remember the rule about the p-value. If the p-value is less than your significance, your level of significance, alpha, you reject the null. So alpha is usually set to 0.01 or 0.05 or 0.1, and these correspond to 1%, 5%, 10% respectively. So since 0.62 is bigger than 0.1, there's no evidence to reject the null. You see, this is a two-tailed test. It tells you what the alternative hypothesis is. The true mean is not equal to 90. It also gives the confidence interval, 95% confidence interval. Now suppose the purpose of this is to show you something else, getting more help. Suppose we want to change the 95% to something else, say 90%. Well, the thing is, guys, with commands, there's often this default settings, and using commands we can alter the default settings. To see what settings we've got for this command t-test, we go question mark and followed by the name of command, so t.test. On the bottom right you see the documentation, and you've got a description followed by, you can see the command here t.test, followed by all the options and all the default the options have been set to, followed by this what those option things have set to is called arguments, and then right at the bottom you can see examples of how to do this. So let's go back to the top. It looks a mess, but if you sift through it carefully, you can see here it says 0.95 conf level, so that's what we need to change. So how to change that is go back up here, comma, and we type that conf.level, see it recognizes it, click on that and change to whatever we want, say we want 0.9. okay, and we run that. Now you see it's changed to 90%. If you look further into the options here, you can see we've got alternatives here, two-sided, less or greater than, i.e. these are one-tailed tests. We can change those. By default the setting is testing that the mean is 0, but we change that. Okay. One thing that you might be wondering about is, does the order of the stuff going in the brackets matter? So here we've got dat. How about if I did it like just throw things around? I separate each of these options with a comma. Okay, I put it that way. Does that matter? Run. Ah, no it doesn't. So it's giving us the answer still. So long as we've got all the options there separated by commas, we're fine. Right, so finish off here, making command 1 sample t-test. Okay, so we'll scroll down, you can see it's pretty neat. I'm going to pretty much understand that. I'm going to save that. Okay, now I've created these objects, I'll save the objects as well. File, I can see all those objects, everything I've created over down here. Right, so R is a great language. It's a constantly evolving language because you've got these things called packages which extend the functionality of R. So when there are new tools that are invented, R users code them up and share them with the community. And how they do that is by creating packages. And if we click on the packages tab here, you can see what the packages we've got loaded, and if we want to install any new packages, press that and install, and then we're ready to go. Okay, so finally guys, there's no one way to usually to do the same thing, so much of it depends on your preference. So there's some guidelines of what's good practice or not. The thing is to get into it, start to play around with it, and soon you develop familiarity with it. Good luck guys with your journey learning R.